Course 3, we've been working with geometry quite a bit lately, including surface area of a cylinder we did last, which was just take the perimeter of the base and multiply that by the height. That gives you the LSA. That's this whole part. And then, of course, you need to find the area of the top and multiply that by 2 to get the bottom as well. That was surface area, everything that covers it up. Volume is base times height, meaning area of the base now. So find this area and then times the height, because you basically think of stacking that area up over and over again as many times as the height exists until you get to the top. So that was volume. Area of base times height. Surface area was, that was volume. Surface area was the LSA plus the bases. With prisms, you could do it a couple ways. For surface area, we learned you could do an LSA, which would be this perimeter times the height, and then add the bases. Or you could just do 6 separate faces, right? Just add all those together. Both will get you the right answer. I kind of like using LSA if you can keep it all straight. Now, volume of this, again, was also base times height. So base meaning 8 times 6 is 48 times 10, which is the height, is 480. In this lesson, we're going to do the same thing. We're going to do volume. We're going to do it for cones. So circular base, rounded top. It's sort of like the pyramid version of the cylinder. And then pyramids, which do have triangular faces that meet at a point and have a rectangular bottom, right? So let's take a look. Basically, it tells us why the formula is what it is. The main thing, if you don't follow this, is that you know the formula, and I'd probably write it on a cheat sheet because, you know, it's not always easy to remember. It's 1/3 of what we just talked about. They explain that if you had a cone that has the same height as the cylinder, because like I said, cones are kind of like cylinders in the way they've got the rounded outside, but we can't do LSA because it doesn't have the same size on the top, right? That's not the case. It comes to a point. It's slanted on the ends, which makes it not work that way. But what's interesting, God's designed cylinders to have this relationship with the pyramids that have the same height. You can fit, that's a terrible drawing of a height. Sorry. You can actually fit exactly 1, 2, 3 of those types of cones, which have the same area bases and the same heights. You get exactly 3 of those in there. So what we're going to do is we're going to find the volume of this, and then we're just going to divide it by 3. Or you could say times it by 1/3. It's the same as dividing by 3. So the volume of a cone, basically find the volume of a cylinder, which we said was area of the base times the height. Area of the base is pi r squared times the height. And then just divide that by 3. That's all you're doing. Area of the base times the height, then divide by 3 to figure out the cone. All right? So just write that formula on a cheat sheet or something and use that. So the tough thing is if they don't give you the picture, you might have to draw that yourself. That's what they do. Their strategy is draw the diagrams. Because in the problem that they actually give you, they just talk about Aiden's cones he's using at the beach, made out of sand. The diameter of the smaller cone means the base, right? The base, which is a circle because it's a cone, is 6 across. Okay, you have to draw that, right? And it's a cone, so it's circular on the bottom, or close to it in my drawing. Height of 5. So you just draw a simple enough diagram that makes sense to you, that this is 5. Okay, 90 degrees. Okay, so to find the volume of that, we need to find the area of the base, which, remember, we don't use diameter for area of a circle. We use the radius squared times pi. And then that gets multiplied by 5, which is the height. And all of that is, right, divided by 3. So 3 squared is 9. Still 9 pi times 5 times 1/3. So 45 pi, I just multiplied the 9 and the 5, divided by 3. Okay? Let's see how they calculated that. Oh, duh. 45 divided by 3 is an even 15. So, a third of the volume of, if this was a cylinder, like this, we're just finding what's a third of that, and that is 15 pi. That's the volume here of this cone. And then this stuff. And we've got a bigger cone that he makes, and they just change the dimensions. Everything else you do the same. So the diameter is 12, the height is 10. So radius is 6, squared is 36, times pi, times height, times a third. Okay, these are all being timesed, being multiplied. So I do these because it's easy. 360 times a third, if you put that in your calculator, 360 divided by 3, I think, is 120. And then we've still got this pi here. So that's the volume of this one right here. This was the volume if it was a cylinder. And then we divided it by 3 because that's its relationship with cones that have the same area, base, and height. Then it finishes by saying how many times bigger is the volume of the cone that's bigger than the smaller volume of the cone. And keep expressing pi as pi. You don't have to calculate the pi, it just makes things ugly. So what we do then is we put the 120 pi, which is the volume of this big guy, right? B for big guy. And then we want to divide that by small guy, by 15 pi. All right? How are we doing? Sometimes these are hard to teach over video, but the nice thing is you can always watch this again, right? You can always slow this down or talk about it with a friend. So when you divide, you cancel out the pi's, and then you do 120 divided by 15. It's not 10. Maybe it's 8. That'd be 120, I think. So it's 8 times greater. And that makes sense because they doubled the dimension. They went from 6 for the diameter to 12. And then since we're doing volume, right, which is right in the 3 dimensions, that's why we do thirds. We cube the scale factor of 2. It makes sense that that would be 8 times greater. Let's see if we got the right answer. And we did. The volumes of prisms and pyramids are similarly related. If a cone was a third of a cylinder with the same area, base, and height, then a pyramid is the same as a prism with the same area, base, and height. You just divide these by 3, right? So the formula for pyramids, which have triangular faces, think Egypt, is actually even simpler. We said the volume of a prism is the area of the base times the height. So just divide that by 3, and you can fit exactly 3 pyramid volumes that reach the very top here inside of a prism. So if they say find the volume of a pyramid, this is a square pyramid because the base is the same on both sides of the square. 90 times 90 is 8,100. That's the area of the base, that's B. Then we multiply that by height, which they say is 50. Everything's in centimeters, so we're good. 8,100 times 50. I better get my calculator. These numbers are getting bigger. 8,100 times 50. 405,000. Divide by 3. Or times a third. Same thing. 135,000 is what I'm getting. Centimeters cubed. Excellent. Now, example 3 is going to help you when you try to do example lesson practice B. So don't get to B and say, I don't know how to do it. Just use example 3 to tell you how to do it. Because as you get further in math, they're going to use ugly things to prove that you can do it even when it gets harder. That you understand what we're doing and you're not distracted by weird looking measures. We have another pyramid. This time it's triangular, but remember we didn't say how to find the area of the base. We just said area of the base. So you find an area of a triangle like you've learned how. You do base times height divided by 2. That would be 12 times 6 square root of 3. Oh, it already told us that. The area of the base is 36. So they gave us the area of the base. It's 36 square root of 3. Okay, and that's ugly. But we know that formula is a third base times height. So you just plug in 36 square root of 3 is the B. Okay? And height is 10. And we divide this by 3. We didn't even need this, honestly. I thought we were going to need all this junk, but they gave us this. So you just take this times this, and you divide by 3. So they're just seeing if you can substitute into a formula and whether you can find 36 times the square root of 3 times 10, basically. Remember how we do these? Sorry if my times signs don't always look like times signs. We just multiply the normal numbers and we leave the radical as it is. So just multiply 36 times 10. What do you get? 360. Okay, and then don't forget, because it's a pyramid, right? Not just a prism, we have to divide all this by 3. We have to multiply by a third. So again, we only work with these. We leave the square root of 3 on there. And we just do 360 divided by 3. That sounds familiar from earlier. The volume then is 120 times the square root of 3. You just leave it that way. That's the answer. Label units cubed. How's that? So you're going to get kind of that in B, because in B they say the area of a hexagonal base. Again, doesn't matter if it's a weird base because we just have to find the area of it. And in this case, you don't even need to find the area of it. In this case, they tell you it's 18 square root of 3. So the part I just colored in's area is 18 square root of 3. The height, right angle from the peak here, is 12. Okay, formula for volume of a pyramid is a third of the base, 18 square root of 3, times height, 12. Substitute in and you've got volume. Okay, that's how much can fill up the whole thing. Good job. And then letter C, they gave you the diameter. You find the volume if the height is 21 inches all the way around. Again, volume is a third of area of the base times that height of 21. Remember how to find area of a circle. If they give you diameter, they're trying to trick you. You don't use the diameter for area of a circle. You use radius, okay? Square that times pi to find this, and then don't forget to multiply the rest of the parts, okay? So do B and do C. Good luck.